Hello everyone, now this will be the last video for the chapter of amines, and the last video here will be the chemical reactions of diazonium salts. Now in the chemical reactions of diazonium salts, they can be broadly classified into two types, that is the removal of the nitrogen and then the retention of the nitrogen group or the diazo group. Now let us check the first category, that is the removal or the displacement of the nitrogen atom. Now this reaction has many types or different types of reaction is given under this process. Now two main important reaction under this process is, the first one is Sandmeyer's reaction and Caterman's reaction. Now these two reactions are, in the first reaction, that is this is A, this is B. Now this is for the displacement of the diazo group. The first group, that is replacement by a halide or a cyanide ion. Now in Sandmeyer reaction, now if consider this is A, now Sandmeyer reaction, this is our diazonium chloride. Now in Sandmeyer's reaction, the category can be divided into three types. The halide ions, that is they are acting as nucleophiles. The halide ions such as chlorine, bromine and cyanide ions can be easily introduced into the benzene ring with the help of a copper ion. Now divide Cu2Cl2 plus HCl. CuCl, it's the same, plus HCl. Here our product here will be chlorobenzene and nitrogen gas will be removed. Now in the second step, Cu2Br2 plus HBr or CuBr plus HBr. Any of the two reagents can be used. In here, our product here will be bromobenzene with the release of nitrogen gas, and CuCN or RCN can be used here as a reagent, and we'll be getting here a cyanobenzene with the removal of nitrogen gas. Now the products of Sandmeyer's reaction are chloro, bromo and cyano products. Now if we check in Caterman's reaction, this is our diazonium salt. Now in Caterman's reaction, chlorine or bromine can be introduced into the benzene ring by treating this diazonium chloride salt solution with their corresponding halogen acid in the presence of copper powder. Therefore, in Caterman's reaction, copper powder is used with the halogen acid. Now copper powder. Now if we use here HCl, we will be getting chlorobenzene, and if copper powder here with HBr, then we will be getting here bromobenzene. Now it is to be noted here that there is no cyano product in Caterman's reaction. Only chloro and bromo products are obtained in Caterman's reaction. Now it is observed that the yield in Sandmeyer's reaction is more and better as compared to Caterman's reaction, and the products also differ because in Sandmeyer's reaction give all the chlorine, the chlorine product, bromo product and the cyano product, whereas Caterman's reaction give only chlorine and bromine, the chloro and bromo product. Therefore this is the first reaction for the displacement of nitrogen. Now the second reaction, which involves the displacement of the nitrogen group, and are diazonium reacts with potassium iodide Then we will be getting iodobenzene here with removal of gas-Cl and nitrogen gas is removed. Now the third is the replacement by fluoride ion. When our benzene diazonium chloride reacts with fluoroboric acid, it gives N2PF4 minus. Notice can also on reacting it gives fluorobenzene with PF3 and then the nitrogen gas is released. Now another reaction we can see here, when this is heated in the presence of copper and sodium nitride, we will be getting here nitrobenzene. This is nitrobenzene. This is known as our nitrobenzene. Now the focus is only on this reaction where the diazonium salt is replaced by the fluoride ion. The fourth one here is replacement by hydrogen. Our benzene diazonium chloride. This is a very important reaction. H3PO3. This is known as hyperphosphorus acid. Now, hyperphosphorus acid, when it is used, it replaces the diazonium salt with hydrogen to get nitrogen gas is released and then HCl. Now, again, this reaction can be used when C2H5OH is used as a solvent. Okay, this solvent is used as a solvent, and this solvent itself is oxidized and it reduces the benzene diazonium salt. The solvent ethanol itself is oxidized and it reduces the benzene diazonium salt. Therefore, we will be getting a replacement by hydrogen, and then it itself is oxidized. Therefore, when alcohol is on oxidation of alcohol, we know that when alcohols are oxidized, they change to aldehydes. Therefore, we will be getting here an aldehyde of the alcohol, and then N2 plus HCl. Now the fifth one is replacement by hydroxyl group, that is addition of OH group. Our benzene diazonium N2Cl minus benzene diazonium salt. When it reacts with water, there will be removal of HCl and nitrogen gas is removed. Therefore, replacement will be done by an OH group, and 2 and HCl will be here. Now the sixth question here, reaction for the displacement of nitrogen is benzene diazonium chloride when it reacts with fluoroboric acid. Fluoroboric acid, it gives us okay, this is the same reaction. It's here. I have done this reaction when it reacts with fluor. Let me do it again here. We will be getting here N2PF4 minus and then plus. Now when this is reacted with NaNO2 and with copper, in the presence of copper, the diazonium group is replaced by NO2 group. This is also an important reaction in the displacement of the nitrogen group. Now our second chemical reaction of the diazonium salts is known as the reactions involving the retention of diazo group, or this is also known as coupling reaction. In this reaction is used for the preparation of dyes. Now dyes such as phenol orange dye and then aniline yellow dye and naphthol red dye are prepared by these reactions, and such reactions are known as coupling reactions. Now in the first reaction, we will be preparation. This is used for preparation of dyes. Now this is used for the preparation of dyes. Therefore, the dyes such as phenol orange dye and then aniline yellow dye is used to prepare such dyes. Now the first one, our phenol orange dye. Now the name itself says phenol, therefore phenol itself will be involved here. Phenol OH. Now for simplification, I'll be writing the dye as one N, triple bond N, this is plus, Cl minus here, and then this reaction undergo under a basic medium, and the pH here is maintained from 9 to 10. Therefore, from the pH we see that the reaction is maintained at a pH at a basic medium. Now, when this one by bond breaks, goes up to addition, goes and adds up to nitrogen atom, the chloride ion. Here we know that there is a hydrogen atom here. Therefore, this comes and attacks with this. Now here, therefore we will be getting here our OH is as it is here, and double bond N, and our benzene ring. Now this is our dye, phenol orange. This is our phenol orange dye. Now since there is carbon to nitrogen coupling is done here. Since there is coupling between the carbon to nitrogen dye, therefore from here we can see that there is carbon to nitrogen coupling. Therefore this reaction is known as diazo coupling reaction. Okay, so now let's check the mechanism of how this dye is prepared in this reaction. Now our phenol here, OH, this is our phenol. Now under a basic medium we will be having here, if a basic medium, the OH takes back this, and then along with the 2 bond it goes to the oxygen atom. Therefore we will be getting here O minus. Now this O minus comes, if it comes here, then this bond will come here, then this comes here. Therefore we will be getting here our oxygen, and then we will be getting here negative sign because there is excess of electron density is increased in this barrier position. Therefore now when this reaction and our diazo, this is our and Cl minus and then plus. Now this negative comes and attacks this pi bond constant adds up to hydrogen. Therefore we will be getting here the carbon to nitrogen has bonded here, double bond N, and then our benzene ring will be here, and Cl minus itself is present in the solution. Now we know that there is hydrogen here. Now the 2 bonding pairs, the Cl minus comes and takes this hydrogen. Therefore there is the removal of minus HCl along with the 2 bonding pair. This goes here. Now this bond comes and moves up here, and then this O bond breaks up and goes to oxygen atom. Therefore we will be getting here O minus and N, double bond N, and then this is the product. Now embotonation comes and takes this, and then this becomes OH, and then this is our phenol orange dye is prepared here. Therefore this is the preparation steps for our phenol orange dye here, and thus in this mechanism we see here that there is carbon to nitrogen. The carbon to nitrogen coupling is done here. Therefore this is known as a diazo coupling, and this is one of the important reactions in the retention of the diazo group, chemical reactions for the retention of diazo group, where dyes are prepared in such reactions. Now then let's check our second dye. Our second dye is known as aniline yellow or para-amino azobenzene. This is known as a para-amino azobenzene. Therefore this reaction, when our this is aniline. We know that there's an H here. When an aniline yellow means aniline would be involved here. Aniline. Now our diazonium. Now from here, when coupling reaction, the same mechanism process takes place. Even in NH2, the same place. Now this Cl minus, Cl minus comes in, it takes up this. Then the minus here comes and adds up. Carbon and nitrogen comes and adds up. And therefore, coupling takes place from carbon to nitrogen bond. Therefore, we will be getting here an H2 and double bond and the mechanism. This is known as the bara-amino azobenzene. Therefore, this is our bara-amino. The amino group is in the bara position. Therefore, bara-amino azobenzene. The benzene. This is known as the aniline. This dye is known as aniline yellow. Therefore, such type of reactions are very important. Diazo products obtained. They have an extended conjugated system having both of the aromatic rings joined through the nitrogen to nitrogen double bond. Therefore, these compounds are often they are colored and thus they are used as dyes. Therefore, in the first reaction, we have seen how phenol react with the diazonium salt to obtain an orange dye where phenol known as the para-hydroxyazobenzene. And then in the second reaction, we have seen the similar reaction where the diazonium salt reacts with aniline to yield the para-amino benzene. Now these are also examples of. This is an example. The aniline yellow, the reaction of aniline yellow with aniline with diazonium salt is an example of electrophilic substitution reaction. Therefore, the mechanism steps in this preparation of aniline yellow will be the same as those that took place in the electrophilic substitution reaction of amines. Therefore, this is the last video for the chapter of amines and the importance of. Since the diazonium salts are used in the preparation of dyes, we see that diazonium salts are very important in the synthesis of aromatic compounds and their dyes. Therefore, in conclusion, we can say that aryl diazonium salts, they are usually obtained from aryl amines which undergo replacement of the diazonium group with a variety of nucleophiles to provide advantageous methods for producing the aryl halides, cyanides, and phenols, as we have seen in the first reaction, that is for the displacement of the nitrogen atom and by reductive removal of the diazo group, which involves the preparation of the dyes. Coupling reactions of aryl diazonium salts with phenols or aryl amines give rise to the formation of azo dyes, and therefore the diazonium salts are very important in the synthesis of aromatic compounds.